Hello students, and welcome to this module of home tutors. This module is based on indices and logarithms. And don't forget, one of the important features of home tutors is that on each subject, on each module like this, after going through the principles involved, we solved for you all the questions on this topic inside your new general mathematics, as well as all occurrences of this particular topic, that is indices and logarithm, in WAEC and JAMB past questions since the year 2000 till date. Let's quickly look at the outline of this particular topic. We will be looking at the laws of indices, and we will be looking at certain problems and solving them. We will be looking at what we call indicial equations and how to go about solving them. We will be looking at the relationship between indices and logarithms. And after that, we will be looking at the laws of logarithms. We will look at problems, and solve them. And then we'll look at logarithmic equations, what they look like, and how to solve them. Laws of indices. For ease of mathematical operations, figures are written in forms in which simple laws can be used to manipulate them without the use of calculators. Normally, this is possible if the numbers can be written in unique forms like this. For example, a raised to power m, x raised to power b, etc. Where a and x are called the basis of the expression and m and b are called the indices. For ease of manipulation, the numbers must definitely have a common base. So the following laws can then be applied. So these are the laws that we call the laws of indices. Law 1 says a raised to power m times a raised to power n is equal to a raised to power m plus n. Second law says a raised to power m divided by a raised to power n is equal to a raised to power m minus n. Third law says that a raised to power 0 equals to 1 for every a not equal to 0. This is where the popular expression comes from, that anything raised to power 0 is 1. So long as a is not equal to 0, any value that a has, once you raise it to power 0, the answer is 1. That is the third law of indices. Law 4 says a raised to power minus m is equal to 1 over a raised to power m. That is, a raised to power minus m is the inverse of a raised to power m. All these laws are true for all values of a, m, and n not equal to 0. Let's see some examples and see how to apply these principles. For example, 10 raised to power 5 times 10 raised to power 4 will give us 10 raised to power 5 plus 4, which is 10 raised to power 9. Take note that before you can apply the laws of indices, the basis of the numbers must be identical. For example, a raised to power m times b raised to power n can never give you this. Before you can use the law of indices, the basis must be identical. I hope you understand that. Now, a raised to power 3 times a raised to power 9 is equal to a raised to power 3 plus 9. That gives a raised to power 12. Okay? 2 raised to power 4 times 2 raised to power 2 is equals to 2 raised to power 4 plus 2, which equals to 2 raised to power 6. M raised to power 8 times m raised to power 5 is equal to m raised to power 8 plus 5, which equals m raised to power 13. You see that before you can apply the law, the basis must be identical. That is the condition under which the laws hold. Now, applying the second law, that's the law of division, which says that a raised to power m divided by a raised to power n equals to a raised to power m minus n. So, c raised to power 7 divided by c. Now, c without an index means c raised to power 1. Any variable without an index means the variable is raised to power 1. So this is the same thing as saying c raised to power 7 divided by c raised to power 1. And that will give us c raised to power 7 minus 1. That gives c raised to power 6. From the third law, 2 raised to power 0 is 1, because anything raised to the power of 0 is equal to 1. Do you still remember? So long a is not 0, anything raised to the power of 0 will be equal to 1. Applying the fourth law, 4 raised to power minus 3 is the inverse of 4 raised to power 3. Okay, that is 4 raised to power minus 3 is equal to 1 over 4 raised to power 3. Good. X raised to power 3 divided by x raised to power minus 5. That gives x raised to power 3 minus 5. So don't get confused here. Alright, because the index here is minus 5. But the fact that we are doing a division, from the law of indices, we are supposed to subtract. So you are going to have x raised to power 3 minus 5. That gives you x raised to power 3 plus 5. And that gives you x raised to power 8. Okay? Now check this out. A raised to power minus 9 divided by b raised to power 0. Take note that anything raised to the power of 0 is equal to what? 1. Alright, so practically what you have here is just a raised to power minus 9 divided by 1, which is the same thing as a raised to power minus 9. But then, what is a raised to power minus 9? From the fourth principle, a raised to power minus 9 is inverse of a raised to power 9. So a raised to power minus 9 equals to 1 over a raised to power 9. Alright, so eventually you will have this expression to give you 1 over a raised to power 9, because b raised to power 0 is already 1. I hope it's clear now. These are still the application of the basic principles. As we go further and further, it gets a little bit trickier and trickier, but I hope at this point it's still clear enough for you to follow. Example 2. Simplify the following: 5y times 4y raised to power 4, and then all the rest. Something you need to take note of at this point is that generally in problems of this sort, the indicial parts are treated separately by applying the laws of indices, while the coefficients are treated with normal arithmetic laws. For example, look at 6x raised to power 3. Now, in 6x raised to power 3, 6 is the coefficient, x is the base, and this 3 is the index. Okay, so this 6 is what is called the coefficients, and then x raised to power 3 is what is called the indicial part, and the indicial part is made up of the base and the index. So in this kind of problem, you treat the indicial parts separately with the laws of indices, and then you treat the coefficient parts separately with the general laws, the normal laws of arithmetic calculations. So therefore, 5y times 4y raised to power 4 simply means 5 times 4 to be treated separately, okay, then times y times y raised to power 4. So in dealing with y times y raised to power 4, remember, y without an index simply means y raised to power 1. So based on the first law of indices, y times y raised to power 4 is equal to y raised to power 1 plus 4. So eventually this expression gives us 20y raised to power 5. You see, we treated the coefficient parts with the normal laws of arithmetic computations, and then we treated the indicial parts with the law of indices. Y times y raised to power 4 will give y raised to power 1 plus 4, which is y raised to power 5. So you get this answer. Okay, the second question says 5x squared times 4x raised to power 0 times 2x raised to power minus 6. All right, take notes. you have to manipulate the coefficient part with the normal laws of arithmetic computation. But then the initial part, you treat them with the laws of indices. So therefore we have 5 times 4 times 2 times x raised to power 2 plus 0 plus minus 6. That is x raised to power 2 plus 0 minus 6. I hope you know how we got that. Because when they have the same basis and then you are multiplying two indices, all you need to do is to just raise the common base to the sum of the indices. So here they have a common base, x, and what you are doing is multiplication. So what you need to do is just raise the common base x to the sum of the indices, that is x raised to power 2 plus 0 plus minus 6, which is 2 plus 0 minus 6. So what do we have? 5 times 4 is 20 times 2 is 40. So we have 40x raised to power minus 4. The third point says 9a raised to power minus 5 times 4a raised to power 6. What do we have? You treat the coefficient differently, 9 times 4, then you treat the initial part differently. And then when they have the same basis, all you need to do is to raise their unique base, that is the identical base, to the sum of the indices, because you are multiplying them. All right, so you are going to have a raised to power minus 5 times a raised to power 6 will be equal to a raised to power minus 5 plus 6. So that gives you 36a raised to power 1, which equals to 36a. Number 4, 3x raised to power minus 3. Remember from the fourth law, when you are raising a number to a negative index, it is equivalent to the inverse of that number raised to the positive index. That is, 3x raised to power minus 3 is equal to 1 over 3x raised to power 3. And what does that give us? It gives 1 over 27x cubed. I hope that is clear, because 3x raised to power 3 is 3 raised to power 3 times x raised to power 3. So that gives 27x raised to power 3. Problem 5. 2 over 3 raised to power minus 1. What does this give? It gives us 1 over 2 over 3 raised to power 1. So eventually that gives us 3 over 2. Question 6 says 15 times 10 raised to power 4 divided by 3 times 10 raised to power minus 2. You can see that you'll have these numbers that have the same base, and then you have the coefficient part. So you can treat the coefficient part with the normal arithmetic principles. That is, you can have 15 divided by 3. That gives us 5. But now, the initial part, you have 10 raised to power 4 divided by 10 raised to power minus 2. When you are dividing two numbers that have the same basis, all you need to do is to raise this, their common base, to the power of the difference of their indices. That is, if you are doing x raised to power a divided by x raised to power b, it should be equal to x raised to power a minus b. So in this case, 10 raised to power 4 divided by 10 raised to power minus 2 will be equal to 10 raised to power 4 minus 2. That gives you 10 raised to power 4 plus 2, and that gives 10 raised to power 6. So this entire expression is equal to 15 divided by 3 times 10 raised to power 6, which is equal to 5 times 10 raised to power 6. And the last problem in this particular example, 26x raised to power 6 divided by 8x raised to power 4. treat the coefficients with the normal laws of arithmetic. 24 divided by 8 is 3. And then treat the indicial part with the law of indices. X raised to power 6 divided by x raised to power 4 is equal to x raised to power 6 minus 4. And that gives x raised to power 2. So this expression reduces to 3x squared. Now, there are some additional laws of indices. Let's quickly look at the remaining laws of indices. Law 5 says a raised to power m then raised to power n is equal to a raised to power m times n, which equals to a raised to power mn. Law 6 says a raised to power 1 over m is equal to the mth root of a. Alright? That is, a raised to power m 1 over m is equal to the mth root of a. And finally, law 7 says a raised to power m over n is equal to the nth root of a raised to power m. These additional laws are very, very important in manipulating indices.